Welcome to this explainer. Okay, I want to start off by painting a picture for you, and honestly, it might be a little uncomfortably familiar. Imagine it's 3 a.m. Your pager is just screaming at you. You drag yourself out of bed, pour a coffee, log into your monitoring systems, and, well, everything looks completely fine. Your dashboards are a sea of bright, reassuring green lights. The CPU is totally normal, memory looks fine, but at the exact same time, your customer support queue is absolutely blowing up. A critical system is suffering from some deep, agonizing mystery that your developers simply cannot solve no matter how hard they look. It's a completely universal frustration, and let me tell you, you are definitely not alone in feeling it. Today, we're going to figure out exactly why that happens. We are going way back to the roots of software engineering to understand the true origins of observability. We are going to uncover why the tools you've been sold for years might actually be holding you back by design, and we'll explore the fundamental shifts required to turn those opaque, hostile production environments into transparent, understandable systems that actually work for the people writing the code. So let's just dive right into this by confronting a really uncomfortable truth: the illusion of control we have over our complex distributed systems. If you look at the modern tech stack today, we ostensibly have more tooling than ever before in the history of computing. I mean, we are literally drowning in endless streams of metrics, logs, and alerts. Yet when something actually goes wrong, when there's an inexplicable slowness with no obvious smoking gun, we often find ourselves completely paralyzed, just staring blankly at our screens. Why is that? Well, it's because as our architectures evolved from those nice, predictable monoliths into sprawling, highly distributed microservices, our failure modes completely changed. The good old days of a system simply being up or down are largely gone. Instead, we live in this chaotic world of partial degradations, hidden bottlenecks, and incredibly bizarre edge cases. Imagine a situation where a checkout button is only failing for users running a highly specific browser version, but only when they are in the Pacific time zone, and only during a massive traffic spike. Standard monitoring is never going to catch that. And honestly, the most frustrating part? The tech industry rallied around a set of observability pillars to supposedly solve this exact problem. But those pillars were never actually built for the developers who are writing the code and trying to hunt down these exact edge cases. And that brings us to the hard truth we really need to face. The dominant model of observability today is essentially just monitoring rebranded. We have to take a hard look at why this happened. Historically, storing data was incredibly expensive. It cost a fortune. So early monitoring tools were fundamentally designed as a survival tactic against these massive storage costs. Their primary function was to cap those costs by aggregating data, literally throwing away the granular, high-resolution details just to save space on a hard drive. They were built to answer questions that operators had already predicted, like, hey, is the memory getting full? But as the massive shift to the cloud forced foundational changes in how we build and deploy software, vendors realized they had a problem. So they simply hijacked the term observability. They took their old infrastructure monitoring and application performance management tools, slapped a shiny new label on them, and sold them right back to us. In doing so, they completely failed the developers who, rather than needing aggregate averages, desperately needed to understand the highly specific, incredibly novel behaviors of their exact code in actual messy production environments. If we look back at the historical timeline, we can see exactly how the loss of in-house operational skill sets paved the way for vendors to sell us this false narrative. Back in the 2000s, tech companies had massive, dedicated operations departments. These incredibly skilled folks ran absolutely everything: DNS, kernels, file systems, literally racking physical hardware in freezing cold data centers. But then, in 2006, the first wave of cloud computing hit, with providers like AWS. Suddenly, you didn't need to run your own physical servers anymore. Over the next 15 years, those deeply technical operational tasks were increasingly replaced by managed APIs and SaaS products. We essentially outsourced our operational excellence. Now, here's a really surprising fact. Post-2006, the sheer volume of telemetry data generated by these sprawling crowd systems completely exploded, growing exponentially faster than our ability to process it. So when the concept of observability started getting real traction around 2017 and 2018, the industry fundamentally lacked the in-house muscle to push back against the vendor marketing machines. Vendors realized they couldn't afford to store this massive new explosion of high-detailed data, so they just buzzword rebranded their existing three pillars, logs, metrics, and traces, and confidently declared that to be observability. There is a sharp, fundamental contrast between tools built for operators and the actual needs of developers trying to validate their code. And honestly, this mismatch is at the very heart of our current debugging nightmare.
On one side, you have the operator or infrastructure mindset. This is traditional monitoring. It asks very binary system-level questions. Are the servers running? Are the CPUs maxed out? Is the network saturated? It is highly aggregate, relying on predictable, known metrics. But on the exact opposite side, you have the developer mindset. Developers do not just need to know if a server is running. Knowing that a CPU is at 90% utilization is completely useless to a developer trying to fix a bug in a specific microservice. They need to know what their specific line of code is doing when a specific user from a specific region running a specific payload interacts with it. They need rich, exploratory detail to validate their intent in production. By forcing developers to use operator-focused aggregate tools, we essentially welded their hood shut and blinded them to how their own code operates in the real world.
The ultimate aha moment for truly understanding what we actually need didn't even come from a Silicon Valley tech startup. It actually came from looking outside of software entirely to a mathematical concept from control theory. Way back in 1960, an engineer named Rudolf E. Kalman coined the term observability. He established that observability and controllability are mathematical duals. Basically, if you cannot observe a system, you absolutely cannot control it. His definition asked a really profound question. Given only the outputs you can measure, can you infer the complete internal state of the system? Think of it like a car engine. If the hood is welded shut, can you successfully diagnose a failing spark plug based solely on the sound the exhaust makes and the temperature gauge on the dashboard? If you can figure out the internal state based only on the external outputs you are capturing, the system is observable. If you can't, some internal state is permanently hidden from you. And here is the brutal truth of control theory. No amount of clever engineering, no expensive AI add-on, and no fancy dashboard can magically recover information that was never captured in the first place.
Control theory brilliantly breaks the circular dependency of traditional debugging, moving us from needing to know exactly what to look for to being able to explore completely novel system states. Let's make this super concrete. Traditional tools are built for known unknowns. A known unknown is something you've actually seen break before. You know the database gets slow sometimes, so what do? You set up a dashboard to monitor database query times. Once you already know you have a problem and you know generally what that problem looks like, you can find it. But true observability flips this entirely on its head to tackle unknown unknowns. An unknown unknown is asking, why do iOS users experience a 5-second delay, but only when adding a specific Black Friday promo code to their cart over a 3G network? No one ever thought to build a dashboard for that specific scenario because you literally couldn't have predicted it. True observability allows you to follow your code into production and be completely surprised by what users are doing, without needing to predict the exact question just to get the answer. A really fantastic analogy for understanding the massive leap from traditional monitoring to true observability comes from the world of finance. If standard monitoring is like managing a simple personal checking account, modern distributed systems require the rigorous observability of a complex global financial institution. Think about it. When you have a personal checking account, it's pretty simple. You set up direct deposits, you auto-pay your rent, and you casually check your balance on your phone maybe once a week. That's monitoring. It's an aggregate view of your financial health. But what if you are suddenly the CEO of a massive global bank? You have to track millions of microtransactions, trace the historical path of every single cent across international borders, drill down into specific accounts on a moment's notice, and detect complex fraud rings dynamically. Imagine the absolute panic of trying to track down a single lost penny in a global banking network using just a monthly printed paper statement. That is exactly what we are doing to our developers today. Going from a monolithic architecture to a massive distributed system without observability is like trying to run a global bank with a pocket calculator and a filing cabinet.
So, with all that context in mind, let's look at how this philosophy actually translates into rigorous technical capabilities. Because we can't just rely on high-minded concepts from 1960s control theory, right? We need a concrete technical specification for our modern software systems. We need a framework that guarantees we can infer that complete internal state just by interrogating the system outputs. Based on the fundamental failures of legacy monitoring and the absolute necessity of capturing those unknown unknowns, 6 distinct, completely non-negotiable requirements emerge for a system to be considered truly observable. Let's break them down. These 6 steps are mathematically perfect for displaying the framework needed to stop guessing and start systematically working from the edge of any problem right down to the correct answer. This is incredibly important, so let's really get into it. First, you need arbitrarily wide structured events. Instead of a tiny log line that just says error, imagine a massive, endless dossier attached to a single millisecond in time.
You need to be able to stuff hundreds of pieces of context, user ID, browser type, cart value, server region, into a single event without any penalty. Second, no pre-aggregation. Think of pre-aggregation like making a fruit smoothie. If you put strawberries and bananas into a blender to space in your fridge, you definitely get a smaller footprint. But if someone later asks you to pull out a single whole strawberry, you can't do it. The detail is destroyed forever. You must store data raw. Third, high cardinality. Cardinality is basically just uniqueness. Gender is low cardinality. There are only a few options. But user ID or shopping cart ID is high cardinality. There are millions of unique values. Traditional tools punish you for high cardinality. True observability demands it because bugs always hide in the unique details. Alongside this is high dimensionality, meaning you can slice the data by many different fields at once. Fourth, trace visualization. You absolutely need to be able to zoom in and visually follow the thread of a single request as it jumps from service to service over time. Fifth, an exploratory UI. We are not talking about a rigid pre-painted dashboard of dials here. You need an open-ended canvas that lets you ask weird, completely new questions on the fly. And finally, sixth, fast queries. If a query takes 10 minutes to load, you lose your train of thought completely. Investigations require flow. Queries must return in seconds to keep debugging fast and interactive.
To truly appreciate where we need to go, we have to recognize that what we call Observability 1.0 is a fundamentally broken state. It's an era where teams literally hemorrhage their most valuable context just to cap out-of-control vendor costs. In this 1.0 era, the industry broadly accepted the three pillars model, but this created an absolute workflow nightmare. You had a tool for metrics, a completely separate tool for logs, and maybe a third tool entirely for traces. The data was heavily siloed. Picture that 3 a.m. scramble we talked about. A developer sees a spike on a metric dashboard. Now they have to jump into a separate logging tool, manually copy and paste a timestamp, cross their fingers, and search. And because vendors charged exorbitant fees for the high cardinality data we just talked about, teams were forced into restrictive sampling. So the developer hits enter on their search, only to realize the exact logline they needed to solve the production mystery was discarded at the source just to save a few bucks on the monthly bill. It is an incredibly painful, fragmented way to work.
Conversely, Observability 2.0 brings an incredible sense of relief. It provides a single source of truth, finally ending the era of investigative dead ends. Instead of splitting your data into arbitrary pillars, Observability 2.0 means you take all of that rich, arbitrarily wide, high cardinality data and you send it into one unified, structured data store. You pay to store it exactly once. The elegance of this cannot be overstated. Because all the context is preserved together in its raw state, the relationships between the data points remain perfectly intact. From that single pool of data, you can view it as a beautiful waterfall trace, where you can slice and dice it like a massive log file, or you can graph it like a metric. You never hit a dead end where you have to jump to a different tool, only to find an empty screen. The data is all there, ready to answer whatever wild question you decide to throw at it. Now, let's talk about the financial reality of this, because this is where it gets crazy. The crucial point is that using the fragmented tools of the past carries a massive financial burden. It often acts as a shocking 20x cost multiplier for every single request entering your system. Just let that number sink in for a second. 20 times the cost. Why does it multiply so fast? Well, according to Gartner, it's totally normal for enterprise teams to use 10 to 20 different observability tools. When you don't have unified storage, you aren't just paying for storage space. You are paying for the compute power to move, transform, and index the exact same piece of data 3, 4, or 5 different times across your network. You pay the vendor to store the log, you pay to store the aggregate metric derived from that log, you pay to store the trace, and then you pay for the massive connective tissue and network egress fees to desperately try and link them back together. It is a massive, completely unsustainable financial waste. So, weaving all these insights together, adopting Observability 2.0 is far more than just a technical upgrade. It is an absolute financial and operational necessity, and quite frankly, a vital cultural shift for any modern engineering team. Moving to a unified data model allows organizations to finally escape that crushing 20x cost multiplier, redirecting those wasted funds back into actual product development where they belong. It destroys the crippling data silos that force engineers into blind alleys during critical outages. But most importantly, it reclaims developer sanity. It gives developers the actual, tangible tools they need to comfortably and confidently validate their code in production. It allows them to slice through high cardinality and high dimensionality context like a hot knife through butter, answering questions no one ever even thought to ask, and beautifully illuminating those deeply unpredictable unknown unknowns. I want to leave you with a provocative thought to really challenge how you view your own production environments and the tools you implicitly trust to decode them. Take a very close look at your dashboards tomorrow morning. If your dashboards are perfectly green, but your customers are actively angry, your support queue is full, and your developers are stressed out and guessing at solutions, you do not have observability. You just have very expensive monitoring. You have to ask yourself, are you building a system where you can actually infer the true internal state? Or are you just paying massive repeating premiums to helplessly watch a system you can no longer control? It's time to expect much more from our telemetry. Thank you so much for joining me for this explainer, and I truly hope this empowers you and your teams to demand true visibility into the software you work so hard to build. Keep asking the hard questions, and we'll catch you on the next one.